Welcome back. Good morning. Welcome to 7.4 factored form of a quadratic equation. Let's begin. So in 7.1 and 7.2, you worked with the standard form, which is y equals ax squared plus bx plus c. Okay. Today we're going to work with the second form of the equation, which is called the factored form. So if you factor ax squared plus bx plus c, it goes into the form y equals a bracket x minus r times x minus s. And r and s are the x-intercepts. Okay? So that's an equation we're going to be using a lot today, momentarily. As well, you don't need that one. As well as an equation for the axis of symmetry, which we used a little bit yesterday, but now you'll have it written down, is x equals r plus s divided by 2. And remember, the r and the s are the intercepts. So as a quick recap, if you have an intercept at -3 and the other x-intercept is at 3, to find the axis of symmetry, which is the line that cuts it into two equal halves, you would go x equals r, -3, plus s, 3, divided by 2. -3 plus 3 is 0. 0 divided by 2 is 0. So here the axis of symmetry would be at 0, okay? So we're going to use these three formulas now, well, mostly the second one here, and see how it helps us. So in example 1, you were asked to sketch the graph of the following quadratic function. Also, we need to state the domain and range. So we're not going to do a lot of questions today because the questions we are doing do take a number of steps, okay? We're going to put over here what we need. To graph this, we need the y-intercept, the x-intercepts, the axis of symmetry, and the vertex. If we have all that, then we can graph it, okay? And we're going to get all of those one piece at a time here. Right now, this equation, it says f of x. F of x is the same. This means the same as y. Sometimes they're used interchangeably. F of x is the same as y. So right now, this equation is in standard form, which is ax squared plus bx plus c. If you recall from yesterday, the c is the y-intercept. So the y-intercept here is 2, okay? The y-intercept is the constant, the number that's by itself. So the y-intercept is 2, okay? We'll need that to graph. We'll graph once we've got all the information. The second step is to factor it to find the x-intercepts. We want to get into factored form. So now you have to sort of go back to your skills you used in Foundations 10 when you learned how to factor trinomials. Okay? To find the x-intercepts, we make y equal to 0. To factor this, the first thing I notice is that we could divide all of these numbers by 2. So we're going to pull a 2 out of each of them, which will give us 2x squared plus 7x plus 1. Oh, this is supposed to be 12. I'm sorry. That's why this didn't make any sense. Make this 12. Okay. No, what the heck's going on here? Hold that thought. One moment. I think it is 12 because otherwise we can't factor it, but I'm just going to double check. Yeah, it is 12. I'm sorry. So 2x squared plus 14x plus 12. So the y-intercept is actually 12. Okay. Now when we factor a 2 out of each of these, we get x squared plus 7x plus 6. Okay. Now, if you remember how to factor trinomials, you need to find two numbers that add to the middle term, which is 7, and multiply to the last term, which is 6. Two numbers that add to 7 and multiply to 6 are positive 1 and positive 6. 1 plus 6 is 7, and 1 times 6 is 6. So now we can write this factored trinomial as 2 times x plus 1, x plus 6. Now you'll notice that we now have it in factored form, which is y equals a times x minus r, x minus s. Okay? So now to find the x-intercepts, we have to make both of these little, both of these binomials equal to 0. Make both of them equal to 0 and then solve for x, and then we will have our x-intercepts. So x plus 1 equals 0, and x plus 6 equal to 0. So we solve for x on both. We'll get x equals negative 1, x equals negative 6. So now we have our x-intercepts, are negative 1 and negative 6. Okay. Once you have the x-intercepts, the next step is to find the axis of symmetry. If you recall, the axis of symmetry is we add the two intercepts up and we divide by 2, because it's got to give us the middle point there. So to find the axis, we go x equals r plus s divided by 2, which is negative 1 plus negative 6 divided by 2. Negative 1 plus negative 6 is negative 7. Negative 7 divided by 2 is negative 3.5. So the axis is x equals negative 3.5. Okay, now the final step before we can graph is to find the vertex. Now the vertex, again, is an x and y coordinate at either the maximum point or the minimum point, basically either the top or the bottom of the parabola. The x of the vertex is always the same as the x value for the axis of symmetry. So you just plug that in. So we know that the vertex is, the x value is negative 3.5. And now we have to find the y value. So what we're going to do is we're going to go back to one of our factored equations. It doesn't matter which one, they'll all give you the same thing. I'll go to right here. So to find the vertex, I'm going to go y equals 2 instead of x plus 1 and x plus 6, I'm going to go negative 3.5 plus 1 times negative 3.5 plus 6. Because I know that's the x value, and now I'm going to solve for the y value. This is going to be 2 times negative 3.5 plus 1 is negative 2.5. Negative 3.5 plus 6 is positive 2.5. And now 2 times negative 2.5 times positive 2.5 is y equals negative 12.5. So the vertex is the x value is negative 3.5 and the y value is negative 12.5. Okay. Give that a quick highlight there. Now we have everything we need to graph this equation. So let's fix that. We go here. We start to write down. Now I know you don't have graph paper. I assume you don't in your book, and that's fine. Graphs will be provided for you on any exams or quizzes. For now, just make a little quick graph. Maybe I'll do it with you instead of on the actual graph paper. So it'll look like this. So let's draw it together. We know that there is the first thing we know is there's a y-intercept is at 12. Y-intercept's at 12 up here. If we go back to our equation, we know that the a is positive, which means this graph is opening up. Okay? So our x-intercepts are negative 1 and negative 6. And our vertex is negative 3.5 and negative 12.5. Negative 3.5 is right in the middle there. Negative 12.5 is probably down here somewhere. And now it's just a matter of connecting your dots. The vertex is the bottom. I'm going to connect up to here and through. And then we're going to try to make the mirror image on the other side. And we are done. Okay? Oh, I guess it asked us for the domain and the range. I forgot. The domain is all of the possible x values, which would be x, e, r, because this graph extends forever, left and right. As far as the range, the lowest y value is right here, negative 12.5, and then it goes up forever. So the range y has to be greater than or equal to negative 12.5. Okay? And that brings us to the end of that first question. As I mentioned, there is a number of steps, but hopefully they were all fairly manageable. Next question. Here we have f of x equals negative x squared plus 6x plus 10. Okay? Now, our goals remain the same, right? Our goals are y-intercept, x-intercept, axis, vertex. Right now we're in standard form, which is ax squared plus bx plus c. And the goal is to get to factored form, which is y equals a, x minus r, x minus s. Okay. Now, there's a slight issue with this one, okay? A couple things. Number one, there's a negative on the x squared, okay? Which we could divide out if we needed to, but the other issue is that our last value is 10 and our middle value is 6, and there is no two numbers that add to 6 and multiply to 10. Agreed? So what we have to do is we're going to have to do something that's called partial factoring, okay? And we'll get to that in just a minute. First, the y-intercept is 10. That's the number that's by itself. The y-intercept is 10. To factor this, we are only able to do a partial factor, and here's what that looks like. We're going to divide a negative x out of just these first two, leaving us with this. Y equals negative x times x minus 6 plus 10. Okay? Now, the purpose of this is is such, and I've got it here, and then I'm going to go back to that slide in a minute, is now we're going to solve for these two pieces, and then that'll give us two x coordinates on the graph. If we can find two x values, we can find the middle of them, which will give us our axis, and then we can find our vertex, and then we can solve it. So what we're going to do is we're going to make y equal to 0, and we're going to solve for both of these two partially factored pieces. This one's not as nice as the last one when we could factor it sort of perfectly, but sometimes all you can do is a partial factor. Okay? So what happens here when we factor these, we get x equals 0, and over here, x equals 6. So what that means is that the two coordinates we get are 0 and 10 and 6 and 10. Because when x is 0, y is 10, and when x equals 6, y is still 10. Okay, so let's put those onto our graph here. Let's go like this. Here's what we have so far. We have a y-intercept of 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a y-intercept of 10, and we have our other number, is at 6 and 10. 1, 2, 3, 4, 5, 6. Okay? We can see that these 2 points are an equal distance apart. Okay? So if they're an equal distance apart, that means that we can now find the axis, which would be in the middle of them. So to find our axis, right here. To find our axis, we're going to go 0 and 6. 0 plus 6 divided by 2. 6 divided by 2 is 3. Now we have our axis. Okay? Again, once we have our axis of symmetry, we can find our vertex. So we take that 3, we plug it back into our initial equation. So y equals negative 3 squared plus 6 to the power times 3 plus 10. 3 squared is 9, and then there's a negative sign, so negative 9. 6 plus 3 is 18, plus 10. So So now we're going to go -9 plus 18 plus 10. The axis point is 19. Or sorry, the vertex, I'm sorry. So the coordinates of your vertex are 3 and 19. So in this case, we don't know what the exact x-intercepts are right now. We just have to, but because we weren't able to fully factor it, we couldn't find those x-intercepts. But what we did find is when we partially factored it, we found the 2 points, and that allowed us to find the vertex, which then allowed us to find the axis, which then allowed us to find the vertex. So now if we were to go to our graph, no, that one's not going to fit on there. I'll have to make another one. So we've got a y-intercept at 10. We've got another point here at 6 and 10. And the vertex is at 3 and 19. So 3 is right between 0 and 6, right? 19's up here somewhere. It doesn't fit perfectly on this graph. Before we draw the graph, if we go back to the beginning, we can see that the A is negative, right? And that means that tells us that the graph opens down, which is good because you can see from this here, this graph is going to open down. So now we have our graph. The exact x-intercepts are unknown right now. You'll get an equation later on that could help you find the exact x-intercepts, but right now you don't need it. We had enough information to solve it. And to get the domain and range, the domain is XER, as it almost always is. The range, the highest y value is 19. The lowest y value is -infinity. So we go y less than or equal to 19. Okay? There won't be a lot of partial factoring questions on your test, if any. Okay? Most of them allow you to fully factor. All right, let's try one more. I think this is the last. Yeah, we'll do 1 or 2 more depending on time here. In this case, so before they were giving us the equation and they wanted us to graph it. Now they're going to give us the graph and they want us to get the equation. So what we're going to look for here is we're going to look for the y-intercept and the x-intercepts first. Let's see if we can see those. The y-intercept is right here at 12. The x-intercepts are at, let's make those green, -1 and 4. Okay? Those are your x-intercepts. Now, let's go to our factored form of our equation. Y equals a times x minus r, x minus s. If you remember, r and s are the intercepts, the x-intercepts. Okay? If I put a -1 in for r, I'm going to get x minus -1. And what does x minus -1 become? X, it becomes +1, so x plus 1. Over here, x minus s, we put in the 4, so it becomes x minus 4. Okay? Now what we need to do is we need to find a. Okay? So to be able to find a, we have to be able to put in, we have to be able to put something in for x and y, right? Because right now we have too many, there's too many variables. There's no way we could isolate the y right now with the, there's no way we could isolate the a right now with the x and y still there. Thankfully, we have another coordinate here, right? We have the coordinate 12 and 0. 12 and 0 is the y-intercept, or sorry, 0 and 12, I apologize. 0 and 12 is the y-intercept. So now we can put an x in for 0 and a 12 in for y, and then we can solve for a. So I put a 12 in for y equals a times 0 plus 1 times 0 minus 4. 0 plus 1 is 1. 0 times negative 4 is negative 4. 4 times negative 1 is negative 4a. Then we divide both sides by negative 4. A equals negative 3. So now we have the value of a. Okay? The goal of this question is to write in standard form, which, if you remember, is y equals ax squared plus bx plus c. Okay? We know what c is. C is the y-intercept. We know what a is. A is negative 3. We have to find b. Finding b is our last step. So to find b, we're going to go back to our factored equation here. Y equals a x minus r x minus s, except now we know what a is. A is negative 3, x minus r, sorry, x plus 1, x minus 4. So now we've got it in factored form, but the question wants it in standard form. So we have to multiply this together. So if I distribute the 3 in here, I'll get y equals negative 3x minus 3 times x minus 4. Then I have to FOIL this, right? I'll get y equals negative 3x squared minus 12x, oh sorry, plus 12x minus 3x plus 12. I combine my like terms in the middle and I get, sorry, I'm running out of room, y equals negative 3x squared plus 9x plus 12. And that'll be our answer. And let's double check that answer quickly. The c is 12, which is our y-intercept, so that stayed the same. That's good. The a is negative 3, which indicates that our graph opens down, which this graph does, right? It opens down. Now we found b, which was 9, and we're done. So, once again, when they give you the graph, you have to find the y-intercept, the x-intercepts. From that you can find a. Once you have a, you can go from factored form to standard form. That'll give you b, and you're done. So let's finish with one more of those. Okay? Oh, sure. I'm sorry, can you say that again?
Could you explain the last thing, like from
Well, I have to get it back to standard form. Right now it's all factored apart. So to get it back to standard form, I have to multiply it together. So I distributed the -3 in there, and then I multiplied these two binomials together. And then once I combine my like terms right there, now I'm back in standard form, which is what the question had asked for. So we had the x and we had the r and s, which were the x-intercepts. We found a, right, over here, and then we just multiplied it together, and that gave us the standard form. Okay. Let's do one more, and then we'll give you time for your assignment. We're going to do, okay, we're going to do this one right here, okay? We'll skip this one. So, let's work on this one together. They want the equation again, okay? So our long-term goal is y equals ax squared plus bx plus c. So we start by identifying our y-intercept and our x-intercepts. The y-intercept is -6, and the x-intercepts are -2 and 6. So if we go into our factored form, y equals a times x minus r, x minus s. We know r, -2. If I put a -2 in here, it's going to become +2. And s is 6, x minus 6. So now we are here. From here, we have to find a. So we sub in the y-intercept, which is 0 and -6 for x and y. Okay. So I put a -6 in for y. -6 equals a times 0 plus 2 times 0 minus 6. 2 and -6 equals -12. So I have -6 equals -12a. Divide both sides by -12. A is 1/2 or 0.5. Okay? However you'd like to write it down is fine. Now that we have a, the last thing is to convert to standard form, which is the one that's way up here. So go back to right here, y equals a x plus 2 x minus 6, except now we know what a is. A is 0.5 times x plus 2 times x minus 6. Multiply that 0.5 into x and 2, which will give us y equals 0.5x, and 0.5 times 2 is 1. Now we're going to multiply that by the x minus 6. Here, here. You probably don't need the lines anymore. We've done this enough, but put them in there anyways. 0.5x times x is 0.5x squared. 0.5x times -6 is -3x. 1 times x is 1x. And 1 times -6 is -6. We simplify this, combine our two middle like terms. Y equals 0.5 x squared minus 2x minus 6. We double check this equation. It's got -6 as the y-intercept, which is good. It has a positive a, which means the graph is opening up, which our graph is doing. So we are good to go. Okay. That brings us to the end of today's lesson. I know these questions are long, so it's good to try a few on your own here. Your assignment, take note of the numbers, page 191 of your workbook, numbers 1, 6, 7, and 10. Thank you. Have a good day.